Greetings, students. Welcome. Today we'll be solving the following problem that you see on the screen. So here it says, a traffic helicopter descends 136 meters to be 359 meters above the ground. What was the original height of the helicopter? Let H be the original height of the helicopter. What is a subtraction equation that models the problem? All right, so two steps here. First, we have to determine a subtraction equation that can help us solve the problem. And then after we set up our equation, we have to solve the equation for the original height of the helicopter. So let's start with what we know. That's always a good idea in any math problem. So let's start with what we know. So here, let's go ahead and I'm going to get a text tool, and it says H is the original height of the helicopter. So H is the original height, right? Then it tells us the traffic helicopter descends 136 meters. So descend meaning it actually approaches the ground. So instead of ascending, going upward, it's descending, which means it's going downward. So we're going to subtract 136 meters. After it descends 136 meters, the problem tells us it is now 359 meters above the ground. Again, it says a traffic helicopter descends 136 meters to be 359 meters above the ground. So this means after the helicopter descended 136 meters downward, it remained at 359 meters above the ground. So we're going to put equals 359 meters. So here we have our equation. This is an example of a one-step math equation. A one-step math equation means you have one computation to make to get the variable h by itself and to solve for the variable. So you only have to do one computation, or in other words, you only have to solve for one step to get h by itself. So in equations, whether they're one step or two step, you always have the variable, which is h. You always have a coefficient. Sometimes here we don't have a coefficient. A coefficient would mean that there is a number next to or in front of the variable. And then we have a constant. 136 and 359, these are our two constants. In order to solve for a variable, you want to ensure that your constant is 0. So when we're solving for a constant, in order to get the variable by itself and to cancel a constant or make the constant 0, it's always the opposite of whatever order of operation you're using. So for example, order of operations include multiplication, division, addition, and subtraction. The opposite of subtraction is addition. In order to make 136 0, we see here we're subtracting 136. In order to make negative 136 0, we have to add 136. So I'm going to go ahead and get my drawing tool, and we're going to go ahead and add 136. And whatever you do to one side of the equation, you do to the other side of the equation. You always have to do both, compute the same steps on both sides of your equation. So now we're going to go ahead and add 136 on both sides. Let's draw our line. This cancels out to 0. H is now the variable left by itself. And now we have 359 plus 136. So we can go ahead and get our calculator. And rather than getting our calculator, actually, let's just add this. Okay. So we have 359 plus 136. So 9 plus 6, what would that be, students? It would be 15. So we're going to write a 5 here. We're going to carry our 1. 5 plus 3 is 8. Plus 1 is 9. 3 plus 1 is 4. So H equals 495. And don't forget to label our answer and put meters. So again, our answer is 495 meters. So that was our starting height. We descended, subtracted 136 meters, and we remained at 359 meters above the ground. The question asks for our subtraction equation. That would be your h minus 136 equals 359. H representing the original height of the helicopter. We solved by adding 136 to both sides of our equation because we needed to cancel out this constant that was attached to our variable h. In order to cancel out a constant, it needs to equal 0. And in order to cancel a constant, you have to do the opposite of its original operation. We know the opposite of subtraction is addition. So we added 136 to make this 0. We're left with h by itself on the left side. 359 plus 136 is 495 meters. So the original height of the helicopter was 495 meters. Thank you for watching.